Welcome back. We're going to continue our discussion on naming compounds, and this time around we're going to take a look at transition metal compounds for the first time. And the first category of it, as I mentioned, is a single metal cation and a single non-metal anion. Now let me put up the rules and put up the table. Not much has changed, but there is one minor difference. As I mentioned, transition metals are usually involved in what is called a variable oxidation number. All right, let me talk about that as I finish this discussion. All right, so the name of the metal is written as it is, followed by a Roman numeral in the bracket. That's the extra addition, and everything else is pretty much the same. Now, transition metal compounds, I can't just give you manganese plus chloride. I gotta actually give you the name or the formula. That's the only way you can work with it because of this exception right here. All right, so let's say I give you manganese. There's a difference between manganese and magnesium. All right, people still, they confuse them. I don't know why. Manganese 2 chloride. So with transition metals, either you must be given the name and write the formula, or you must be given the formula and write the name. Only with alkali metals, I can write like name, and then we can come up with the actual name and the formula. All right, that can be possible with this. So this is actually the name. I've given you the name. So we're going backwards. Instead of naming, we're actually given the compound and write the formula because that's easier to visualize and then go back and actually learn how to name. Okay. Manganese 2. Well, first you need to know the symbol for manganese is Mn. What does this 2 is? That's the charge. It's actually easier to work with transition metal compounds. The 2 goes with the metal, not with the non-metal part of it. So manganese 2, and it's a metal. Metal can only be plus, so 2 plus. Chloride is this, which is, well, chloride is the name, and chlorine is Cl, which is, well, chloride comes from chlorine, right, which is 7B, right? And that is 8 minus 7, I'm sorry, 7 is 1. So it's 1 minus, you've done this before. So the actual formula for is swap MnCl2. There we go. So when given a name, to write a formula is always the easiest thing there is, provided you remember how to approach it. But let's say I give you this chromium, say this. I ask you to name it. How do we write it? Well, first you gotta get to this intermediate state. You gotta get it to the ionic, which is why I was emphasizing why we need to do this in my previous videos. Okay, without that, it's always going to be difficult. Unless you're a trained eye, then you can write it without doing it, like I can do it without having to go through this, but most of you can't do that. So let's swap it. So the 6 come over to the top, and it's a metal, so plus. There's nothing here, so that's a 1. So that goes here, so 1. And chlorine or chloride is a non-metal, so it's 1 minus. So how do we write the name? This is chloride, so that's the last name or the second name. The name of the metal is written first with appropriate Roman numeral in the bracket. Cr is chromium, and in bracket goes what? Well, there's 6, so 6. This is only doable when it's a transition metal. Let's do one more example. Say SZN3P2. Okay. Well, first you gotta, whenever you gotta figure out a name, you must go to the ionic state. So 2 goes here, 3 goes here. Don't worry about the charge right away. First, put them in the appropriate places. Zinc is a metal. It's a transition metal, so it's plus. Phosphorus is a non-metal, so it's negative. It's just that simple. Now go ahead and write the names. Zinc for zinc. P3 minus is phosphide because it comes from phosphorus. Again, if you want to verify it, you can also do that. Phosphorus is 5B, which is 8 minus 5 is 3. See how it works out. See, chemistry is so beautiful. It works out. It's just some random compound, but we are only able to get the 3. We're not able to get 4. We're not able to get 2. Phosphorus would always end up being 3. That's magnificent. So this is phosphide, right? Well, again, for online people, phosphide has to come from phosphorus, all right? Or phosphorus goes to phosphide. So this is what you need to write, not what's on the side. That's the parent. This is like a daughter, and daughter what gets used. And what goes in the bracket? There may be some controversy here, but you know what? I'm going to stick with what I said. The 2 goes in the Roman numeral. If you don't write it for this particular compound, this very compound, that's okay, but I'm not going to explain why. Just going to leave it at that. So write whatever the charge on the metal inside the Roman numeral, only for transition metal compound. Don't do this for alkali and alkaline earth metal compound. So let's do one more for good measure. So let me give you a name this time and have you write maybe the compound. I have given you titanium 4 oxide. Well, first write the symbol Ti for titanium. It's not Tl, that's tantalum. And the 4 goes with the titanium, so it's 4. And titanium is a metal, so plus. Oxide comes from oxygen, so O. Even if you don't know what it is, it's all right. Oxide comes from oxygen, right? O. And oxygen is 6B, so 8 minus 6 is 2, and oxygen is a non-metal. Very good. Now swap, everything will make sense. Ti2O4. Now, this could also be a controversial topic. Do we leave it here or we go one more step down? Whenever you have common denominator that can be divisible further, you can write that, which means divide this by 2, divide this by 2. So it's TiO2. Both are correct. Ti2O4, which I had earlier, and TiO2, they're both correct. Is that clear? And that's why I picked that particular compound, so I can show that in some multiple choice exams outside of my class, you may get titanium 4 oxide, but you would not see Ti2O4 as an option. You would only see TiO2. And you know why? Because they both share a common denominator, so you can divide by 2. All right. Now, this is how you deal with a transition metal compound, a single metal cation and a single metal anion. Okay, you should be able to go from the name to a compound, compound to a name. I'll see you back with the other domain. All right, so stay tuned.